we are going to understand three important aspects of a relationship. First one is the relationship degree, second one is the multiplicity, and third one is the optionality of a relationship. Now degree specifies how many entities are involved in a relationship. So in the first example over here, I shown an employee-manager relationship. Now manager is also an employee. So an employee is related to another employee who happens to be a manager. So there is only one entity involved in this relationship. So such kind of relationship is known as binary recursive relationship. The word recursive over here signifies that an entity has relationship with itself. In the second example mentioned over here, we have two entities having a relationship. So this is a binary relationship, and this is perhaps the most common form of a relationship. If three entities are involved in a relationship, we call it as ternary relationship. Now similarly, there can be more than three entities involved in a relationship, but frankly this is a very rare case. Now the second aspect of a relationship is the multiplicity or type of a relationship. Now type or multiplicity signifies how many entity instances are involved in a relationship. So what exactly are the entity instances? So as mentioned in the first diagram, a table or an entity comprises of individual row or tuples. Each individual tuple is an entity instance. So we have three cases of multiplicity: one to one, one to many, and considering this from opposite side, many to one and many to many. In one to one relationship, one instance of both entities are related to each other. So an employee can have one parking space, and a parking space can be allotted to one employee. It's denoted by one or dash on both sides. Similarly, for one to many relationship, a department can have many employees in it, and an employee can belong to one department. So department with many employees is shown using this crow's feet symbol. It can be shown using an N over here or an asterisk over here. And one employee belongs to one department, which is shown using a dash over here. Just don't worry about how we mark this as the one side and this as the many side. We'll be discussing a technique which will show you how to jot down this one and many notation. Now the third type of multiplicity is many to many. Now a class can have many students in it, and a student can be studying in many classes. Now the third aspect of relationship is the optionality. Optionality specifies whether the relationship is compulsory or optional. For example, in the first case over here, an employee can be allotted a parking space, or the employee is not allocated a parking space. The optionality is shown using a zero symbol on the optional side. So an employee has 0 or 1 parking space. That is, we can say that an employee can exist with or without a parking space. In the second example, a department can have 0 or more employees working in it, and an employee can belong to a single department. So a department can exist with or without any employees in it. Many a times it happens that few entities share some common attributes. In such a case, what we do is we put the common attributes in the supertype and we put the specific attributes in the subtype. Such type of relationship is known as generalization relationship. It's denoted using a U subset symbol in the ER diagram and is shown using an arrow pointing towards the supertype in the UML diagram. The D in the circle over here stands for disjoint. It means that the subtypes are disjoint from each other. For example, a daily wage employee cannot be a salaried employee, and a salaried employee cannot be a daily wage employee. They are totally disjoint. So in generalization, several types of entities with common attributes can be generalized into a common supertype.